Hello, in this video we will talk about the quotient of two complex numbers. Suppose you have two complex numbers z1 which is a plus b iota and z2 which is c plus d iota. So suppose these are two complex numbers such that the second number is non-zero. So if these are two complex numbers such that the second one is non-zero, then the quotient is defined as z1 by z2. z1 is a plus b iota and z2 is c plus d iota. This is the quotient. But the quotient must be the complex number, but this is not the standard form of the complex number. The standard form of the complex number is this form, something plus some other thing times iota. But this is not in this form. How can we convert this thing into this form? We can use rationalization. How we have studied in the previous video that if we have something in the denominator which is a complex number, then you can get rid of the denominator, the complex number in the denominator, such that if you take the conjugate of the denominator, for example, what is the conjugate of this number? The conjugate of this number is c minus d iota. What does that mean? The conjugate is obtained by taking the real part as it is and the imaginary part with the flipped sign. If this sign is plus, make it minus. If it is minus, make it plus. So this way you can take the conjugate of the denominator. What you have to do, if you have this quotient and in the quotient you have complex number in the denominator, then you can multiply and divide by the conjugate of the denominator. What's the conjugate of the denominator? It is c minus d iota. So I'll multiply and divide by c minus d iota. Okay, so what will happen then? You have to simplify these calculations. You will multiply the numerator with the numerator and denominator with the denominator. In this way, first of all, you will multiply a with c, which is ac. Then you will multiply a with minus d iota, which is minus ad iota. Then you multiply this with c, which is bc iota. And then you will multiply this term with this one, which is minus bd iota square. And similarly, multiply the denominator with the denominator. Multiply c with c, it is c square. Multiply c with minus d iota, it is minus cd iota. Now multiply d iota with c, you will get plus cd iota or dc iota, it's the same thing. Now multiply d with minus d, which is minus d square, but iota also iota square, okay? Because this term also has iota and this term also has iota. Okay, now this term and this term will cancel out because both are same but with the opposite sign. Okay. This is AC minus AD iota plus BC iota. This iota square is minus 1 and this minus 1 will make it plus. So I will make right here plus BD and this iota square will be cancelled with this minus. Okay, because iota square is negative, so negative and negative will be cancelled. C square minus D square, again this is iota square. Iota square means negative 1. Okay, write this thing also as the product of negative 1. What does that mean? This minus BD as it is, and then iota square equal negative 1. Okay? Make another step. It is AC minus BD iota, minus AD iota plus BC iota plus BD, because this minus will kill this minus, it will be plus BD. Similarly, this minus will kill this minus, it will be C square plus D square. Our aim is to write the answer in this form. Okay, here we should have some number and some number times iota. The first number must be totally real without iota, right? So first of all, I will extract the real part, separate the real part. This is the real part, this is the real part because they don't have iota. So I will write AC plus BD. I think I have done a mistake before when I no, there is no mistake. Everything is fine. Okay, so what I have done, I have separated real parts. I have written down the real part first. This one is the real part and this one is the real part. So I have written down these two things, BD, and then this is the part with iota and this is the part with iota. So both are imaginary. So I will write them in this way, plus BC minus AD. Since both have iota, so I have written iota with them, with both of them. Okay, now divide by C square plus D square. Okay, since our aim is to convert into this form, now you can check this is real, this is imaginary, real part and imaginary part. So I can distribute the denominator with the real part as well as the imaginary part to convert this into this form. So AC plus BD divided by C square plus D square. Okay, now I will distribute this thing over the imaginary part also. So the imaginary part is BC minus AD times iota over this denominator, C square plus D square. So this is the way how we can calculate the quotient of two complex numbers. Here is an example. You have to calculate 3 plus 2 iota over 5 plus 2 iota. So what we will do, 3 plus 2 iota, 5 plus 2 iota is equal to 3 plus 2 iota, 5 plus 2 iota. The first step is to multiply and divide by the conjugate of the denominator. What's the conjugate of the denominator? It's 5 minus 2 iota. So I will write this term up and down, okay? So 5 minus 2 iota, 5 minus 2 iota. Then I will multiply the numerator with the numerator and the denominator with the denominator. How can I multiply? First I will multiply 3 with 5. 3 5 times 15. Then I multiply 3 times negative 2 iota. So negative 6 iota, okay? Then I multiply 2 iota with 5. It is 10 iota. Then I multiply 2 iota with negative 2 iota. It becomes negative 4 iota square. Okay? Now I will multiply the denominator with the denominator. 5 times 25. Then 5 times negative 2, which is negative 10 iota. Then 2 iota times 5, which is plus 10 iota. Then 2 iota times minus 2 iota square, which is minus 4 iota square. Okay? Now I will simplify the terms. Negative 6 iota plus 10 iota. Negative 6 plus 10 is plus 4 iota, right? I mean, if I add these two terms, it will be plus 4 iota. And what is this? Negative 4 times iota square is minus 1. I will write here minus 1. These two terms will be cancelled. 25 minus 4 times iota square is again minus 1. 15 plus 4 iota minus 1 times minus 4 is plus 4. 25 plus 4, because minus 1 times minus 4 is plus 4. Okay, 15 plus 4 is 19. So I will write 19 plus 4 iota over 29. What will I do now? I will distribute this denominator with the real part. This is the real part. And then with the imaginary part. It is 19 by 29 plus 4 by 29 iota. This is the answer. In the next example, we have division by pure imaginary number. In the previous example, we had division by a complex number which was mixed one. Mixed means it had real part as well as imaginary part. It was neither pure real nor pure imaginary. It had both parts. If we divide something by pure imaginary number, what will happen then? Look at an example. 3 plus 5 iota divided by 7 iota. What will I do? I will write 3 plus 5 iota divided by 7 iota. I have to again multiply and divide by something. That something is the conjugate of this number. What's the conjugate of 7 iota? Since 7 iota can be written as 0 plus 7 iota, because I told you previously in the previous videos, every pure imaginary number can be written as 0 plus that number. So what's the conjugate of this term? The conjugate of this term is the real part as it is minus imaginary part, which is minus 7 iota. So I'll multiply and divide by minus 7 iota. Okay? Okay, now what will I do? I'll multiply the numerator with the numerator and the denominator with the denominator. Multiply 3 with negative 7, negative 21 iota. Now multiply this with this one, negative 5 7 times 35 iota squared. Similarly, multiply this with this one, 49, negative 49 iota squared. Negative 21 iota plus 35 iota square is minus 1. Negative 49 times minus 1, because iota square is again minus 1. 21 iota negative 35 over 49. Okay, because minus is plus. I can write the real part first, imaginary part then. So negative 35 plus 21 iota divided by 49. We need this form. That means we will write the denominator over the real part and then over the imaginary part. Okay. So I will write negative 35 by 49 plus 21 by 49 iota. If they are cancelled at some point, you can cancel them, because both of them are cancelled at 7. 7 5 times 35, 7 times 49, 7 3 times 21, 7 times 49. So this is the simplest form. If you don't want to write in the simplest form, you can write this form also. So this way you can take the quotient or the division. You can divide any two complex numbers. Make sure that the dividend must be non-zero.